So this is the second page of activity B. So we just finished um, question 3. Now we're on to question 4. Gather data, click reset, and turn off show rulers. The power of the wave is the amount of energy it transmits each second. The power of the wave is displayed below the spring when play is pressed. Record the wave power for each of the settings below. So I won't go through all of these, but I'll definitely show you the first one. So you want to go and check your amplitude. You want to make sure your amplitude's at 20. It says it wants the frequency to be 0.60. It wants the tension at 2, and then it wants the density at 1. So what you'll do is you'll hit play, and it wants the power, so you're wanting to write down 0.402 watts. You'll write that answer where it says power. So go ahead and finish all those measurements, and you'll see how amplitude, frequency, tension, and density work together to increase or decrease the power or wattage. All right. Which factors increase the power of the wave? So are you going to talk about the amplitude, the frequency, the tension, or the density? Which ones increase the power of the wave? And you can see that they increase. These grayed out areas are the ones that are increased. So you'll see which one actually has a big impact in your answers. Compare. Click reset, select longitudinal waves, set the amplitude to 20 centimeters, frequency to 0.60 hertz, tension to 2 newtons, density 1, and click play. So we're going to pause this, reset it, transverse to longitudinal. They want us to take and set the amplitude to 20. They want us to put the frequency at 6 or 0.6 hertz, which mine is already set at. The density is at 1, so I'll increase it all the way. And then tension is set at 2 newtons, which mine is already. You hit play, and then you can look over here and it'll show the power wattage in the right after wave speed. Go ahead and write that down in the question number 5A, where it says what is the power of the wave. Compare the power of the transverse wave with the same settings. Does changing the type of wave affect its power? So what you're going to want to do is reset it, change it to transverse wave, make sure that your different settings are the same. So we have 20 amplitude, tension is set for 2, frequency 0.06 or 60, excuse me, and then your density is set at 1. If you hit click play, was there a difference between the wave powers? Go ahead and answer that into 5B. All right, moving on to number 6. These are questions that you must answer. You can look them up if you cannot find the answers, but if you're writing it and it has absolutely doesn't make sense, I would ask me, the teacher. Apply. Sound waves are longitudinal waves that can travel through air. Would you expect sound waves to travel faster as low density gas such as helium or high density gas such as carbon dioxide? Justify your answer based on what you have learned. So that's asking you is, will sound travel faster through helium, which has low density, or carbon dioxide, which is high density? And all you have to do is run two longitudinal waves and just increase and decrease the density, and that should help you find that answer. All right, and you can justify it. That's a big thing that they want you to do in these state tests, is justify with your evidence. Apply. As ocean waves approach the shore, friction with the ocean bottom causes them to slow down. If the frequency is the same, how does this affect the wavelength of the waves? So go ahead, do your best to use examples explaining how frequency, um, if frequency is the same, what will that effect be on the wavelength of the waves? Right. Good luck with that. That'll be finish up part B. Part C, you'll be doing independently, so read the questions carefully and answer them to the best of your ability.